Heat and temperature. In this module, you will learn about the concept of heat and temperature. If you touch a cup of tea, it feels hot. If you touch ice cubes, we feel cold. It is very important to quantify and measure the difference in warmth of an object. This need introduces us to the concept of temperature. Temperature is defined as the degree of hotness and coldness of an object. Temperature is measured by an instrument called a thermometer. The SI unit of temperature is Kelvin. 273.15 K is equal to 0 degrees Celsius. Let's now learn to calibrate a thermometer. For this, first place the thermometer in ice and mark the melting point of ice, that is 0 degrees Celsius, as lower fixed point of the thermometer. Next, place the thermometer in boiling water such that it does not touch the boiling water that shows the temperature of the steam. The boiling point of water, that is 100 degrees Celsius, is marked as the upper fixed point. The separation between these two fixed points is divided into 100 equal divisions, each representing a temperature difference of 1 degree Celsius. Temperature is often thought to be the same as heat, but this is not true. Though they are related, but there is a difference between them. To understand the difference, consider a glass and a large vessel, both completely filled with hot water at the same temperature. Though the water in the glass and the vessel are at the same temperature, the vessel has more heat as it has more mass. Heat, thus, is a total amount of energy in the substance, whereas temperature is the average energy of the molecular motion in a substance. Consider two glass containers filled with water. One container is at 70 degrees Celsius and the other at 20 degrees Celsius. The molecules in the water at 70 degrees Celsius will vibrate more vigorously than those in the water at 20 degrees Celsius. Why do you think this is so? The molecules in the water at 70 degrees Celsius vibrate more vigorously because the average energy due to the motion of molecules in hot water will be more than that in cold water. You will now learn how heat and temperature are related. Consider water in a beaker at room temperature. If you heat the beaker, you can easily make out that there is a rise in the temperature of the water. This indicates that as heat increases, temperature also increases. All you can say is that the average energy due to the motion of the molecules also increases. When two bodies at different temperature are brought in contact with each other, heat flows from the body of higher temperature to the one at lower temperature. The flow of heat continues until both the bodies attain the same temperature. At this stage, the two bodies are said to be in thermal equilibrium. Consider two beakers, one containing 250 cubic centimeters of water and the other containing 500 cubic centimeters of water. If you heat the water in both beakers at 100 degrees Celsius, you will observe that 250 cubic centimeters of water takes less time as compared to 500 cubic centimeters of water, you can conclude that where there is greater amount of the substance, the greater the heat required to raise its temperature. Two different materials also require different amount of heat to attain the same temperature. In this module, you learned that temperature is defined as the degree of hotness and coldness of an object. It is measured with the help of a thermometer. The SI unit of temperature is Kelvin 273.15 K is equal to 0 degrees Celsius. Heat is the total amount of energy in a substance, whereas temperature is the average energy due to the motion of molecules of substance. As the heat increases, temperature also increases. Heat flows from the body at a higher temperature to a lower temperature until both attain the same temperature. The greater the amount of the substance, the greater the heat required to raise its temperature.
Have you ever rubbed metal continuously with its surface? If so, you would have noticed that metal gradually changes its shape. It expands, therefore, there is change in either its area, volume, or shape. These are all the effects of thermal expansion. So, what is thermal expansion? It is a process in which a body expands in either area, volume, or shape when heated. Thermal expansion occurs in solids, liquids, and gases. First, let's consider solids. When a solid is heated, it expands in size and shape, resulting in an increase in length, area, or volume of the solid. This is known as a thermal expansion of solids. But what makes a solid expand? When a solid is heated, the molecules that make up the solid begin to vibrate. This takes up more space and the solid matter expands. Let's see an example of expansion in solids. When you can't open a tight jar, it is recommended that you place it under hot water for a minute. The metal lid will expand because it heats up and won't be so tight anymore. Now, you can open it easily. Next, let's study thermal expansion in liquids. Like solids, liquids also expand when heated. However, since liquid particles are usually less tightly bound to other particles, they generally move further than solid particles when heated. Hence, liquid expands more than solid when exposed to the same temperature. In a thermometer, mercury is an example of expansion in liquids. When we increase the temperature, the mercury starts to expand, and we can clearly see an increase in the level of mercury. Finally, let us see how gases react when they are heated. Gases expand most when heated. This is because gas particles are far apart and are weakly attracted to each other. It is much easier for them to move further than solids or liquid particles when heated. Heat causes the atoms of the gas to vibrate and take up more space. For example, the gas gauge on a car. People are much more likely to run out of gas in the summer than in the winter. Why is that? Well, the gas in your car expands just like everything else, and it changes the reading on your fuel gauge. In the summer, gas takes up more space in the tank. So, when the fuel gauge reads empty, It indicates that there is significantly less fuel left in the tank than it would be during winter. You may get an extra 35 miles after the fuel gauge shows empty in the winter, but that won't be the case in the summer heat. So, be careful. You don't have to walk 3 miles to the gas station just because you don't know about thermal expansion. Let's summarize what we learned today. Solids, liquids, and gases expand when heated. Thermal expansion causes an object to expand when heated. Gases expand most when heated.
Energy is transferred to its thermal energy store, and its temperature increases. The process of heating, though, can take place in 3 different ways, depending on the medium involved. For solids, heat is transferred by conduction. In fluids, it's via convection. And to get through empty space, heat has to be transferred in the form of radiation. Let's start with conduction. The key idea behind conduction is that vibrating particles transfer energy to neighboring particles. To understand how this works, let's imagine that you were heating one end of a piece of metal with a Bunsen burner. And imagine the piece of metal as a series of particles. As the end of the metal is heated, energy is transferred to the metal, or more specifically, is transferred to the kinetic energy store of the particles at that end. This causes the particles to vibrate faster, and so they collide with their neighboring particles more often, and with more energy. As the collisions transfer kinetic energy, the neighbours will also vibrate faster, and collide more with their neighbours. And as this process repeats, energy is passed along the piece of metal, until in the end, the heat is spread out evenly, and it will be pretty much the same temperature everywhere. Now, the reason that conduction occurs mainly in solids is because the particles in a solid are held together really closely, which means that there's lots of collisions that pass on the energy. Whereas in liquids and gases, the particles are all further apart, and so they don't collide as much. Exactly how well objects transfer energy by conduction is known as their thermal conductivity. Metals have a high thermal conductivity and transfer heat energy rapidly, whereas plastics have a low thermal conductivity, which is why we use them as insulators. And pretty much all fluids have a low thermal conductivity. Convection, on the other hand, occurs mainly in fluids. And remember, fluids can refer to anything that can flow, so both liquids and gases. Because the particles in fluids aren't fixed, once they're heated and they gain kinetic energy, they all move around faster. By the process of random diffusion, this will cause these more energetic particles to move away from the warmer region towards the cooler region. And overall, this means that the higher energy particles in the warmer region are a lot more spread out than those in the cooler region. So effectively, the fluid in the warmer region actually expands as it heats up, and so becomes less dense than the cooler fluid. To understand how this works in real life, let's imagine that we had a container of fluid, so that could be either liquid or gas. As we heat the container, the following things would happen. First, the particles near the heat source would gain kinetic energy and spread out, becoming less dense. Because they're less dense, these particles rise above the colder, less dense particles above them. And at the same time, these cooler particles sink down and take their place. Whilst this is happening though, the hot particles would lose their energy and cool down, and the cool particles now at the bottom would heat up. Because of this, the cycle would keep on repeating for as long as the fluid was being heated, and we call this cycle a convection current. We actually see these convection currents all over the place, from oceans to inside buildings, where radiators warm the nearby air and set off the cycle. On the other hand, to reduce convection, we need to stop the free flow of fluids, which is all we're doing when we sleep under a blanket at night, which is stopping the warm air from escaping. What conduction and convection have in common is that they both involve particles gaining kinetic energy. It's just that in conduction, only the energy is transferred between the different particles, whereas in convection, the particles themselves move. However, heat energy can also be transferred without particles, which means it could travel through a vacuum. This happens when energy is transferred by radiation, and specifically when the energy is carried by infrared waves. All objects constantly absorb and emit radiation, and in reality they do both at the same time. Importantly, the hotter the object is, the more radiation it emits. This is why it feels hot to put your hand over a barbecue, even if you're not touching it. The very hot metal and coal is emitting infrared radiation, which is absorbed by your hand. We take a closer look at infrared radiation when we cover the electromagnetic spectrum.